Hey, good morning or afternoon there, Algebra 2 people. Today, in today's video, I'm going to discuss writing the equation of a line. Now, I'm going to do this in two segments. I'm going to do what's kind of known as the basic typical equations of lines, and then I'm going to kind of pause the video because I don't want to go over 30 minutes per video. I don't think I will, but it's going to be a close call. So I'm going to just kind of do these key examples, and then I'm going to make a second video of what I would call maybe some slightly different, maybe special cases of writing the equation of a line, like what happens that is out of the ordinary. Okay? The problems that I'm going to show you, unless otherwise noted, I'm going to take what's known as the y equals mx plus b approach, which is the slope-intercept or slope-y-intercept version of these lines. Ultimately, I am ready to write the equation of a line if I know two key things. Do I know the y-intercept, in other words, where the line crosses the y-axis, and two, do I know the slope? As soon as I know those two things, I'm ready to write the equation of a line. If you will notice on the three examples I have here, now this segment of the video is going to have 5 examples, so I'm going to pause and put a couple others up there. But the 3 that are sitting in front of you, you know basically the same information, it's just things get a little bit different as we go. I know a point that is on this straight line, and I know the slope of this straight line. Okay? And so that's what we're going to be dealing with. Please understand, we're not graphing in this section. We graphed in the last section, but if I asked you to graph this line, say, hey, I want to see this line. I want to physically see the line. You could plot this point on an xy axis, which is 5 starting from the origin, is 5 to the left and 2 up. And from that location, because the slope is 3, think of that please as 3 over 1. That's rise 3, run 1. So I could, from that point, rise 3, run 1, and I could draw the line. So the line exists. We want the equation. Now, we are going to use the y equals mx plus b approach, meaning within this equation, the variables that are in this equation stand for the following things. M is your slope. B is your y-intercept. We talked about that in the last video when we graphed some things. The x and the y that's in this equation stands for all the points that are on a straight line. So let's look at what we have here, folks. I don't actually have the y-intercept. I have the slope, so I can label that M. And I have this point. Now points are xy coordinates, so I can label this x and y. Now please understand, to write the equation of this line, you and I have to know M and B. We know M. We don't have B. I have enough to find it though. So you guys, we're going to take this x, this y, this m, and we're going to plug it into the places that it's supposed to be. We'll solve for B. I'm guessing you maybe have done this before, like in Algebra 1. So here we go. In place of the y, we will put 2. Please understand before I do this next substitution, the m and the x, by the way they are written, means m and x will be multiplied here in a second or two. So y equals m is 3, times x is -5, plus b. We are in the process of solving now for b. First thing after I substitute is multiply those m and x together. So 2 equals 3 times -5 is -15 plus b. Please understand, it's a common mistake. I don't know if common is the right word, but it's popular enough that I am going to mention it. You're solving for b, so this -15 is going to move itself. Folks, that does not say -15b. It's got a plus sign here, meaning you're not dividing right now. This is an addition-subtraction situation, so you're going to add or subtract to deal with it. Now it has to do with the sign that's on the number, not this plus sign. The sign that's on the number is negative, so we will add 15 to both sides. 2 plus 15 is 17. Negative 15 plus 15 cancels to 0, and we get b equals 17. Folks, as soon as we know m and b, we can write the equation of the line. And when you write the equation of the line, the variables x and y go back to being x and y. See, realize that's one single point on the line. X and y represents every single point that's on the line, which is technically infinitely many because the line goes in directions and never ends. So this is y equals m3 x plus b plus 17. So you guys, we now know that this line will hit the y-axis at 17, just quite high on the y-axis, and has a slope of 3. We already knew that. Okay, so there went all the explanation. Now we get to kind of go through these a little bit quicker because they're kind of repeated, but we just want to make sure we're keeping track of sign and all that. Okay, just looking at my notes over there a second. Here we go. This is x. This is y, because it's a point, and slope is m. You're going to notice in many of the examples we see in the 2 video segments, it's very popular to know x and y and m and solve for b. We may have to do a little bit more work to get to that location, but ultimately a lot of times we end up knowing x, y, and m. We solve for b. So here we go, very similar to last time. I'm just going to use the guideline over there to start plugging things in. So it'll be y equals m times x plus b. Just following that guideline right there. Next step is always to multiply the m and the x together because they're substituted now. So this is negative 3 equals 2 times 7, which is 14, plus b. Solving for b, when you're at this location, solving for b is always add or subtract to both sides. It's never divide. So because that is a 14 positive, we will subtract it from both sides. Negative 3 minus 14 is negative 17. 14 minus 14 is 0, and the b is left over. So this time, b is negative 17. Total coincidence here that they're the same number, but one's positive, one's negative. There's no connection. Let's understand that. That's my y-intercept. That's my slope. There's my equation of my line. Y equals m2 x minus 17. So I know it says mx plus b, but if b is a negative number, I write minus. This would say that I have a y-intercept of negative 17, which is way low on the graph, and I have a slope of 2, so rise 2, run 1, rise 2, run 1, and so on. This example is not that different, folks, but it does bother people because they're looking at the slope and saying, oh, it's a fraction. I understand that. Now, one, if I'm being perfectly honest, you should know how to work with multiplying fractions and, if necessary, adding and subtracting fractions. You've learned that in your lifetime. Secondly, you also have a calculator to help you along the way, but ultimately you should know how to do it. I'm going to do it. I'm going to calculate it out with no calculator. Anyway, same boat here. This is point xy, slope m. So substitute like I did before, y equals mx plus b. There's y. Equals m times x plus b. Now, I wrote this way because technically as I get ready to multiply this is like over 1. And I'm going to kind of do this the way that I wish you could do it on your own. Negative 1 equals. Your next job, as has been in the first 2 examples, is once m and x are in place, multiply them. Folks, fraction times fraction is just numerator times numerator, denominator times denominator, reduce if necessary. So if I multiply the numerator, it's 3 times negative 8, or negative 24. 4 times 1, which is 4. See, the negative is on the 8. You keep the negative on the 8, not the 1 also. Plus b, that reduces, which I'm going to take a second to do that. So that's negative 1 equals, folks, negative 24 divided by 4 is negative 6. Plus b. So to solve here, Solving for b, because that's a negative 6, we're going to add 6 to both sides. So plus 6 plus 6, negative 1 plus 6 is 5, negative 6 plus 6 cancels b. b equals 5. So we write y equals m 3/4 x plus b plus 5. So you guys, there's the basics of the first three. I have two more examples in this video segment, which this video segment's going to be relatively short-ish. And then that's going to be the end of this small video segment, which is just, again, the key basic idea of writing the equation of a line. Let me pause and get a couple examples up here. Alright guys, so we're ready to continue here. Now I have two more examples, that's all that's in this segment here. So it says write the equation of the line described. And this time, as you can see, the two examples say the line through, and I just give you 2 points. Now number one, again, I think it's always important for you to realize, oh, we are talking about a straight line and we're just not seeing it. But you can understand I could plot this point, which starting from the origin, if I was graphing, is 1 to the right, 2 down. Put a dot, and then from the origin, 5 to the right, 10 up. Put a point, and I can connect those 2 points. There's the straight line we're talking about. We're going to write that equation. And I said in the first segment, the first 3 examples, to write the equation of a line, 2 things need to be known by you. What is the slope? That I don't know this time. And 2, what is the y-intercept? I still don't know that. I didn't know that in the first 3 examples, and I still don't know that. So, you guys, the issue is, if you're given 2 points that the line passes through, you need to calculate the slope. Right here is the slope formula. You have seen that before. As promised, when we get around to test time, that formula will be on the top of the test or on the back of the test or whatever. You should know that formula. It's basically the formula version of rise over run. Because rise, what goes this way? The y-axis. Run, what goes this way? The x-axis. So see, rise, change in y, run, change in x. Basically spelled out, second y-coordinate minus the first y-coordinate, second x-coordinate minus the first x-coordinate. So, you guys, when we're given 2 points, we're going to label them x and y. But we're going to label the first point 1s, the second point 2s. So, this is x1, y1, basically for xy point 1, and this is x2, y2, basically second point. So the first thing we will now do is substitute those values where that formula says. It's basically a replacement. So it'll be y2 minus y1. So y2, 10, minus. See, always write that minus sign down because that's built in, and then write exactly what y1 is. y1 is negative 2. Folks, please understand, minus negative is plus. So you will see me change that to a plus sign. That's why I'm changing the color so you can see it on the video like, oh, he changed that. It originally said minus negative. The denominator is x2, 5, minus x1, which is 1. Folks, remember that was minus negative, so now it's plus. 10 plus 2 is 12. 5 minus 1 is 4. 12 divided by 4 is 3. There is the m. Now, the next steps are similar. You've seen these. Here's the difference. We are going to take the y equals mx plus b approach. Here's the deal, folks. I have a choice to pick either point. I can use either one of these points as my xy. This is my m. I'm still solving for b. Now, you are free to choose whichever. It doesn't matter. If you say, I like this point because the numbers are smaller. Some people are like, well, I don't like the fact that that's got a negative, so I'm going to use this points because the numbers are just 5 and 10. They're easy. You pick. B will come out the same provided you don't make a careless mistake along the way. I'm going to use the 5 and the 10 just because. So where I see the y, I will put 10. Where I see m, I will put 3 that we just calculated together, times x. X is 5, plus b. Please understand, if you chose to use the other point, -2 is sitting there for you, and +1 is sitting there for you. The 3 is still 3 because it's all the same slope and so on. Okay, let's finish this solve. Folks, we get 10 equals 3 times 5 is 15 plus b. We subtract the 15 from both sides. 10 minus 15 is -5 equals 15 minus 15 cancels, and we got b. b equals -5. So here's m, here's b. The minute I have those two things documented, I write my equation. So y equals m3x plus b, I'll say -5. And that's the end of that. There's the equation of that line. If you plot these 2 points and connect a line, or go to this y-intercept and rise 3, run 1, you are on the same line, identical. Okay, over here, folks, I can go a little bit quicker now because it's going to be a repeat of the steps. The formula is still sitting over there. By the way, that formula needs to be in your notes. If we quiz on this particular lesson, that formula is your responsibility in terms of a quiz. It's my responsibility in terms of a test. Okay, so here's our points. We will label those x1, y1 for first point, x2, y2 for second point. We will calculate the slope according to that formula over there. So y2 minus y1. x2 minus x1. -5 minus 9 is -14. 8 minus 6 is 2. -14 divided by 2 is -7. Folks, there is our slope. Maybe circle it and label it M. Folks, we are in the same boat as we were last time in that I have my slope. I have 2 points to choose from for my x and y. You choose what you want. What looks easiest to you. Now, last time I chose the point that had both positive numbers and did it. This time I'm going to choose the point that has a negative number involved. So I'm using this as my x and y as opposed to this. You are free to use 6 as your x, 9 as your y. So following the y equals mx plus b model from over there, y is -5 equals m, -7 times x, which is 8, plus b. Y equals mx plus b. As usual, for the 5th example in a row, we're solving for b at some point. This is -5. -7 times 8 is -56 plus b. Solving for b, I told you we always use add or subtract to solve for that, because that number is negative, we add 56. So -5 plus 56 is 51. -56 plus 56 cancels. B equals 51. Kind of a crazy example to think about, but I'll explain why it makes a little bit of sense. So y equals m, -7x plus b, plus 51. What you have to understand with this, it would be fairly easy to plot these 2 points, which is 6 to the right, 9 up, and this is 8 to the right, 5 down. This has got a really steep slope going down, and that's, look, it's -7. For every 7 you drop, you only run 1. 7 you drop, run 1. So that's why the y-intercept is 51, because and that's unreasonable. That would be terrible for me to ask you to graph that, because you would have to scale up to 51. It would be so much easier just to plot those 2 points. So, folks, that is segment 1 of this section. I'm going to end this video and do a second session for the other one, because then I'm going to discuss some special cases. Like what happens when the line is horizontal? What's the slope look like there? That's kind of weird. What happens if a line is vertical? What's the slope look like there, and how does that play into writing the line, writing the equation of the line? So there are some special cases that need to be talked about, and that'll be in the next video because this one will go too long. All right, take care.